Hello guys, I'm Vinay Pandey. Let us solve KVPY 2018 SX Part 1 Chemistry question number 41. Question number 41 says the amount in mole of bromoform CHBr3 produced when 1 mole of acetone reacts completely with 1 mole of bromine in presence of aqueous NaOH. No? It's a very simple question. It is a question of haloform reaction actually. So let us check haloform reaction first of all, right? It is the case of haloform reaction, and haloform reaction, bromoform in this case actually. So what happens basically, you see in reaction with acetone and bromine, right? In reaction with acetone and bromine, we get CHBr3. CHBr3 and the other part of the molecule gives carboxylic acid. This is in presence of NaOH, of course. So what is the mechanism? Let us check what is the mechanism, and then we shall find out how many moles of bromine are required for the formation of 1 mole of bromoform. Okay, 1 मोल ऑफ ब्रोमोफॉर्म के लिए कितने मोल्स ब्रोमीन के Br2 के यूज होते हैं? सी इन फर्स्ट स्टेप in first step basically this base takes away this H plus. Suppose this OH minus is taking away this H plus, so it forms carbanion. This carbanion attacks on Br2, right? It attacks on Br2 in a fast step. This was a slow step. Now it's a fast step. And when Br2 comes here, it becomes alpha bromo acetone, right? Now the reaction will not stop here because OH minus will again take away this one alpha H plus, and it becomes this, and rather this carbanion is more stable because of the presence of Br at this carbon, right? Again this carbanion will attack on the other mole of bromine, okay? So you can check, this is the second mole of bromine being used here, right? So you will find that now it is dibromo, right? It is dibromo, C double bond O, CO, CS2, right? Again OH minus will take away the only H plus present at alpha position, so it will form again after removal of H2O. Every time H2O will be removed when OH minus takes away the alpha H, then you will get this kind of an ion which is more stable than the previous carbon ions, right? And this carbon ion again will attack on bromine molecule like this, right? So this way you can see the third mole of Br2 is being used for ultimately tetrabromo acetone. But the reaction doesn't stop here. Actually OH minus will attack as a nucleophile at this carbonyl carbon first, and this after this carbonyl carbon is attacked by OH minus as a nucleophile, then you will see that C double bond O is broken. And when the C double bond is broken, this negative charge again will fight back for the formation of C double bond O, because presence of C double bond O will give thermodynamic stability to the molecule, as C double bond O is very strong bond. When it comes back for double bond formation, then either CH3 will go out or CBr3 minus will go out. Both are carbanions. Carbanions are not the good leaving groups, but if you have to compare the leaving ability of these two, then CBr3 minus is better leaving group than CH3 minus. So this is CBr3 minus, and plus you see C double bond O, OH and CH3. ठीक है ना? Now acid is having H plus and base required, so H plus transfer takes place, and this way we get bromoform along with sodium salt of carboxylic acetic acid in this case, of course. This bromoform this bromoform was formed when you used 1 mole of acetone, right? And total 3 moles of Br2. You can see 1 mole of Br2 was used here, second mole of Br2 was used here, and third mole of Br2 was used this side. Okay, So for formation of 1 mole of CHBr3, we require 3 moles of Br2. So 1 mole of Br2 will basically produce 1 by 3 moles of bromoform, right? See, 3 moles of Br2, 3 moles of Br2 produce 1 mole of bromoform, right? That we saw in the mechanism. So 1 mole of Br2 will produce how much bromoform? 1 by 3 mole of bromoform. That's very obvious and very simple calculation. That means our answer for this question must be A. So the answer to this question is A. Okay, guys. Simple question, reaction based question. If you know the direct reaction, then also you can find the answer. Otherwise, you can go through the mechanism. Please stay tuned for the next question.